Hello, welcome to our first lecture in MySQL. So here's our assumptions. You have MySQL Server installed, MySQL Workbench, and the sample database classic models. You'll find instructions on installing the MySQL software and the Workbench on the tutorial site www.mysqltutorial.org. You also find the sample database that we'll be using, classic models, there. So that indeed forms our text, www.mysqltutorial.org. Not only the sample database and installation instructions, but you'll find a fairly thorough set of lessons on SQL there. So what's the database? A database is a persistent collection of information organized in such a way that a computer program can quickly access and select the desired pieces of data. Persistence is important. It means the software system can be restarted and the database still be there. A simple file under this definition could be considered an application database. All software that presents custom data content have a database in the back end serving up data. So that, for example, when you log into your bank and you get your bank account information, there's a database in the back end that's serving up that data. The database then forms the core of these systems, a vital core of all of these systems. Very important topic. So from a very general idea of what a database is, just being a persistent store of information that allows us to quickly access it, to a very specific type, the Relational Database Management System. An RDMS is a database that stores data in a structured format. It's very formal. It uses columns and rows to form a database table, not unlike an Excel spreadsheet. The columns define the data stored, the name of the data column, and the data type stored there, with rows forming the data. Here's an example of a database table. The columns define the data. Up the top, the name, and underneath the data type. We don't see visibly the data type here, but we see the name of the data column here, and we can infer the data type. For example, employee number, that looks like an integer to me. Last name, that looks like it's probably a string of some sort. So the table itself should define one business entity. For example, the employees data, where we store information about our employees. Relationships among tables. It's the R in the RDMS. A single table is a single entity, but the relationships between the tables form the business systems. Let's take a look at this example here. We have the employees table, and this is another view of the employees table that we saw in the previous slide. It in fact defines the columns, and here you see the column names and their data types next to them. This is the way the integer is expressed, and this is the way a string is expressed in our RDMS system. It has a relationship here with customers' data, and you can see the relationship by the lines that are drawn here. These are actually formal relationships that are defined in the database tables themselves, and we'll see later on how these relationships get formed. How is it used? For example, you're in front-end customer support, and a customer calls in, and you look up their information. They have a problem with an order. From here, the sales representative employee number is a relationship back to the employees table where you can find contact information about their sales representative. This relationship is a one-to-many relationship. So the one side looks like this, and the many side looks like this with a bird foot at the end of it. So one employee, one customer support representative, could have many customers, whereas a single customer, being a single row in the customer's table, has only one employee that's their representative. Now we call this a one-to-many relationship, but it's really a zero-to-many relationship, because if you're an employee that's not a sales representative, you may not have any direct relationship with a customer, so you may have no customers that ties to you. So it should be zero-to-many, but we call it one-to-many. So this is actually an EER diagram, the entity relationship diagram for this database table. And this is classic models. This is the database that we're going to be using for our exercises. So we're going to get to know all of these tables and all of their relationships as we go on. So RDBMS, and SQL. The Relational Database Management System is a theoretical description of a database system. It was developed at IBM in the early 1970s by the researcher E.F. Codd, who wrote the paper, A Relational Model of Data for Large Shared Databanks. That's the start of the whole system. A SQL system, then, is an implementation of the theoretical description RDBMS. And so SQL is what we're going to be studying. So SQL varieties, SQL implementations. First came commercial implementations coming about in the late 1970s, about 10 years after, a little bit less than 10 years after E.F. Codd wrote his paper. Oracle was the first mover here, but also IBM had DB2. Well, those are still products, and the Oracle Corporation, that's still their central product. It's just called Oracle, the Oracle database, but it's a SQL database. And then about 10 years after that, Microsoft entered the fray with Microsoft SQL Server. Also happening in the 80s was PostgreSQL, an open source implementation of SQL, along with what we're studying, which came about in the mid-1990s, MySQL. Open source means that you can get the software for free, and you can become a developer of that software by becoming a contributor to the open source system. So two different cultures here, the commercial implementations mostly used by banks and corporations, and open source implementations typically adopted by startup companies, such as Facebook. Facebook uses MySQL as their database. Why would a startup want to choose an open source implementation? Because it's free. MySQL actually became very popular because it was shipped on Linux systems. It just came along with it. So if you're a young computer programmer in your college dorm room and you're starting a company, you have a Linux system, you have MySQL is right there, already installed. So many internet companies, because of that, started using MySQL, and as the companies grew, MySQL became entrenched as a database system. We also should note MariaDB, which is a fork of MySQL, very similar to it. It works the same way. Its motivation is that along the way, Oracle became the owner of MySQL. Well, open source people don't like that. So the originators of MySQL database forked the MySQL codebase and started MariaDB to get out from under the Oracle umbrella. Now, as we're studying SQL, we're going to learn a specific example, MySQL, but all of these languages have similarities to them, so the underlying ideas are the same. Of course, as they develop, they have specific differences, and you can become an Oracle specialist or a Microsoft SQL Server specialist, etc., MySQL specialist. They all have specialized knowledge because they all have specialized implementations and things where they differ from one another. But their core ideas are still the core ideas of the relational database management systems that E.F. Codd wrote out in his paper in 1970. So as we study this, we're studying a lot of different implementations that you can learn about the details of later. We should also mention SQLite. SQLite is a very simple implementation of SQL that removes a lot of the enterprise support and just makes a fast and simple database. That's on your phones. So if you have an Android phone or an Apple phone, it has a SQLite installed on it to form a local database for apps that you might download. SQL is everywhere. So just to clear up some SQL meanings and pronunciations and spelling, SQL meanings. So it means one thing, a structured query language, and that's what we're going to be studying. It's a single-purpose programming language that defines data, stores data, and reads data. So Java, for example, can be described as a multi-purpose programming language. You can do many things with it. SQL has one purpose. It's all about data. So it doesn't do user interfaces. It doesn't do anything else. It stores, manages, and reads data. So that's one meaning of SQL, the language itself. But it can also be the database installation. SQL machines are single purpose in a large installation. Or the entire database system, both the client and the server, can be called SQL. So SQL pronunciation and spelling. Sometimes pronounced SQL, that's the way I do, but I also say SQL. So neither one of them wrong or right. That's just what you'll see in the culture. All right. In the next lecture, we'll get into MySQL Workbench and MySQL itself. Thank you.